Hello everyone and welcome. In this lecture we'll look at decision trees and random forests. Let me give you an overview of what we will do. We'll start by looking at a dataset from a lending club, and what this dataset contains is a couple of columns that has information about credit history, interest rate, installment, accounts, and so on. So what we'll do is we'll use those information to decide whether a person will get a good loan or a bad loan. Once we look at the dataset, we'll use a decision tree classifier model to build our model and check out if our decision tree does well or not. And after that, we'll consider random forests. Okay, let's start by looking at the dataset. As usual, we import numpy as np, pandas as pd. I copied this from the previous lecture. Okay, now let's use pandas read CSV method to check out our dataset, and I'll save it in a variable called loans pd.read CSV. Then this is the name of the file, lending club data01.csv. Paste it here and run it. Let's check out what it looks like by calling the head method, loans.head. Okay, so these are the columns that we have: interest rate, installment, open account, revolving balance, total account, bad loans, and grade number. What we'll do is we'll try to come up if a person will get a good loan or a bad loan. So whether the loan is good or bad will be our target, and we'll use all these columns except our target column as our features. Let's check out let's get some information about our dataset. I'm going to call the info method. So we have about 1468 rows and 8 columns. The size of the file is about 92 kilobytes. And you can check out the last 5 rows of your dataset by calling the tail method. Okay, that's what it looks like. What we'll do next is let's add a new column, and we'll call that column good loans. And we'll use this bad loans column and map it to our good loans. So we can set our good loans values 0 and 1 to yes and no. So we'll apply the lambda function, and we can set 0 to yes and 1 to no. Let's go ahead and do that. So the name of our new column will be good loans, and we'll use the bad loans column to create our good loans column, and we'll apply the lambda function. So what I will do is call the apply method and then pass the lambda function. So let's say lambda y, we can say yes if y is equal to 0, else no. We can do that. Okay, now let's look at our loans dataset. So if we call the head method, we have a new column here, good loans, and the results are based on what we have for bad loans, 0 and 1. We set 0 to yes, 1 to no. What we'll do next is define our features and targets. So for our features, we'll use all the columns except the bad loans and good loans columns. And for our target, we'll use the good loans column. So let's do that. We'll save our features in a variable x, and then let's use the drop method and then drop the columns that we don't need, which are bad loans and good loans columns. So we can call the drop method and then pass the column names. We'll pass them as a list. So bad loans and good loans. And we're dropping the column, so we'll pass an axis value of 1. That means to drop the columns. And for our y, which is target, we'll use the good loans column, good underscore loans. Now let's check out the shape of our features and target x and y. So print x.shape, y.shape. So our x's, or our feature, 1468 rows by 7 columns, whereas our y, our target, is 1468. Okay, 2-dimensional and 1-dimensional. Now that we have our features and target, what we'll do next is use the train test split method to split our dataset into training and then testing datasets. Once we have that, we'll build our decision tree classifier model, and then we'll use that model and use the training datasets xtrain and ytrain to train our model, and we'll call the predict method to make predictions using the testing dataset. Let's do that. So we'll start by importing the train test split method from scikit-learn. So from sklearn.cross-validation, let's import train test split. And let's also import our decision tree classifier library. That's also from scikit-learn. From sklearn.3, it's in 3, import decision tree classifier. Decision tree classifier. You don't have to memorize where all these libraries exist. You can simply Google them. Okay, so from sklearn.3, import decision tree classifier. Now let's split our dataset into training and testing datasets, and we'll save them in 4 variables: xtrain, xtest, ytrain, and ytest. Xtrain, xtest, ytrain, and ytest. So we'll set that to be equal to train test split, and we'll pass our features and target x and y, and let's pass the test size attribute and set it to 30%. Again, this is optional. If you don't pass that, the default value will be used. And let's also pass the random set attribute and then set it to, let's say, 124. If you want to get the same result as me, you can use the same random state, 124. So we'll use 70% of our dataset for training and 30% of our dataset for testing. Now let's check out the shape of our training and testing datasets. Let's print xtrain.shape, xtest.shape. So our training dataset is 1027 by 7. So 1027 is 70% of 1468, what we had earlier. Okay, and if we print the shape of our ytrain and ytest, you will see that your training dataset is 70%, whereas our testing dataset is 30%. Now we can build our model. We'll start by instantiating our decision tree classifier model. So decision tree classifier. Let's save this in a variable called model. Once we instantiate our model, the next thing we'll do is call the fit method on our model so that we can train our model using the training datasets xtrain and ytrain. So let's pass xtrain and ytrain. Okay, so these are the default values used for our decision tree classifier model. If you are interested about them, you can check out the documentation on scikit-learn. Now that we have trained our model, let's call the predict method and then pass our testing dataset xtest model.predict and then pass our xtest, and we'll save this in a variable called prediction, and we'll set that to be equal to model.predict. Okay, what we can do next is evaluate our model. And we can use confusion matrix and classification report for evaluation. Okay, once we import them from scikit-learn's matrix, we'll use them for evaluation, and that's what we'll see in the next lecture. Thank you, everyone.